Hi ROS developers, and welcome to this new ROS video series about creating your own projects in ROS Development Studio. So if you want to learn anything about ROS, this is your channel. ROS navigation, ROS with drones, autonomous cars, anything related to ROS, you can find it in this channel. Learn ROS step by step and push your ROS learning in just a few minutes of seeing a video and so on. So I'm Miguel Ángel Rodríguez, and today we're going to start a very special project which I'm very excited about, which is creating your own hopper robot. So let me show you a video of what we want. So basically what we want is to create this. So it's a robot that hops around in a simulation and moves just with one leg. Yeah. And for that we are going to use different tools. It depends on how the project develops, but we'll try to use this tool, for example, which is called Tower. And also this tool is created by Inertias. So a shout out to them for creating these tools. So we are going to see if we can use it and so on. And then we are going to try also to use OpenAI to move our hopper in a way that it learns how to move by itself, like this simulation did, okay? And all of that we're going to try to do it in Gazebo. Yeah. How are we going to do it? Well, we are going to use basically as starting point a URDF that these guys from Inertias did of this hopper around here. And as extra exercise, please try to do the other robots, like the four-legged ones or the biped. So it would be amazing that you would post your videos and your projects in the comments down below. It would be amazing. So let's get started. But first, before starting anything else, remember to visit the Robotic Night Academy, our online academy where you will find practical online courses using simulated robots. You don't need any installation, and you will find the link to the academy in the video description below. So now let's get started. So the first things first, you have to open your ROS development environment. In this case, we are going to use ROS Development Studio for this, which is an online ROS development platform. So if you sign in, it's totally free. So you can use it as you want. And when you sign up and so on, you'll get something like this with all your projects. So let's close this stuff because we don't need it anymore. Okay. And you will be greeted with something like this. So you have to create a new project, put a name like this, and say, hey, this is my name, like blah, 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 blah. Okay. I have one created already for you. So I open the project. No, in this case I don't. Okay, and we have this blank canvas to start working on. So the first thing is we are going to open our beloved IDE. There you go. And we have these workspaces. So for development of simulations, you have to put all your code in the simulation workspace. If you work locally, you just put it in your CAD/CAM workspace, that's fine. But in ROS Development Studio, we have this division because it's simpler, so that you put all the programs that are not simulations, like AI learning, I don't know, any kind of program that you can imagine that it's not related to the simulations, you put it in the CAD/CAM workspace. But if it's a simulation, you just put it here in the simulation workspace. So as you can see here, we have already have something because I prepared the project beforehand, but we are going to start from the beginning. So the beginning is, let's open a web shell. Yep. As you can see, we have all these workspaces. We go to simulation, source, web, and here we go. So we do a catkin create package, then the name of the package. So in this case, I don't know, let's put the same name that we have in the example that I've prepared. Not the same, but more or less the same structure. So legged robots description. Let me copy. So this is very important in ROS. It's not a very good idea to have two packages with the same name. It would generate conflicts and you won't be able to compile. So there you go. And now we put the dependencies. In this case, ROS by will be enough. For the moment, we can add dependencies afterwards, and we create it. Okay, so now we have legged robots description. As you can see, we can create packages inside folders, like for example these. This is a folder, locomotion. It's just a folder that has more packages. Okay, yeah. So we are going to create one that it's called my legged robot description, and we're going to create another one which is sim. Okay, just like this ones. Okay, my legged robots sim. This is for we're going to see it afterwards, but basically is because it's a good practice to put descriptions, a package with all the meshes in one side, and put all the simulation launches in another one package. Normally it's called Gazebo extension, but you put any name you want. Okay. So now let's have a look. Okay. So inside it, the first thing we need is these meshes. Okay. So we need the meshes for these models, specifically the one for our beloved monopod. Okay. So what you have to do is just clone it. So you do copy, paste, and you go here and you do git clone, and this one. We have already done it. So basically you have here XPP. So let's have a look what's inside. So inside we have loads of stuff, but what we need now is this. And more specifically, we need only the URDF, which is monoped URDF, and the meshes. Okay, so let's have a look. So in the description, we're going to copy the meshes. Copy and paste. There you go. And in the URDF, so in this legged robot sims, we are going to copy the URDF. So we don't need all of them. So we can just, I'm going to copy and then delete. Yep, paste. And then we are just going to delete the ones we don't need, which is basically all of them except the monoped. Delete. But as I told you, it would be amazing that you would create the other ones. So try the other ones, because for example, the four-legged robots are more stable because by themselves they can stay upright. Monoped and biped, it's impossible to make them stand by themselves if you don't have like a movement dynamics. So as you wish. But we are doing monoped just because the URDF is simpler. Okay, so here we have monoped. So let's have a look. So this, we can close it and we put this. So having a look at the URDF, we can see that it's quite simple. So let's have a look. So basically we have a robot tag here, and then we have a link, some links which are basically the base. So if we go here, you see the base is the squared element, and then we have some more elements here that are just the leg. So we have here the base, which is a box. Then we have the hip assembly, the upper leg and the lower leg. That's it. And then we have 3 joints, which is basically the hip, and the other hip element, and then the knee. That's it. So can we simulate with this? We can't, because this doesn't have any physics elements, any collisions, nothing, any mass, any inertias, nothing. So you can't use this to simulate anything. This is just for visualization, to use it in, for example, RViz. You can use this, but you can't use it to simulate. So how do we turn this into something that can be simulated? So the first thing, we are going to just copy and paste, and we're going to, this is something and we're going to do, for example, let's put the same name that I put here, just to be control. Yeah, so let's look. Okay, no, we can't see that. There we go. Okay, URDF. Okay, so what do we have here? So let's close this one and let's start. So the first thing we have to do is basically add the physics elements. So I'm going to open the one that it's already done, and we're going to see the differences and how to do it basically, and then we'll copy paste. So what's the difference between this base here and this one here? Well, we have 2 more tags. We have inertia and we have collision. These are very necessary elements to simulate, because you need inertia to simulate physics basically, and collisions also to simulate collisions, otherwise it will go through the floor. Okay, so we just have to copy paste if you want. The mass, as you can see, the mass is totally arbitrary, so I didn't go and build a real robot and then weigh it. Just put a mass that it's more or less sensible, and then calculate it. You can calculate it depending on what you want and how, but you can calculate this through our tool that is ROS Spawn Tools Inertia Calculator. And here you just have to specify the box. For example, I have a box, let's see, for example, we have a box, and then the mass, what let's say is 0.18, and the width it's 0.20203, 0.2, 0.2, and 0.3. And then we have this calculation. So as you can see, it's not perfectly made actually. So we have 0.0195 and here, but basically we have an inertia. Okay, so you can calibrate this, and there you go. For non-geometric shapes, it's a bit more tricky, but basically the best way to do it is just doing a bounding box of the model. So let me show you, because it's quite important. So we go to our let me just, where we go? Descriptions, yeah. So I want to show you how to get the meshes right. So how to get the inertias right with meshes, which is quite important. So how do I calculate the inertias for this, for example? How do I do that? Well, if we go to our my leg, blah, 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 and we go to leg and hip assembly die. Yeah, we have a die here. So if we download this, and then if we download this and we open it with, for example, Blender, I think it's the best tool to do this. So once you have this, you import die and we get the hip assembly. Then you hit N and you see here you have more or less the dimensions in units. So if we go here, metric, so here you have the dimensions of the element. So this is the bounding box. So if you go here and you put bounding box, is this box. So the inertias, you can calculate them based on these dimensions. It's a very well, it works really, really well. So you have to put these measurements in meters in the inertia calculator, and that's it. Yeah, just a point to do this. Okay, so what more? So let's go again to this. So how do we do it? So basically we have to, in the base, for example, add inertia and collision, and also you have to add the gazebo element so that it's simulated in Gazebo. Otherwise it won't work well. So these are basically the components for how the material reacts to pressures. So this is the static pressures and this is the dynamic. So how if you have a very low number, it will deform very easily, like gum. But if you put a number very high, then it will be like rock, so very stiff. And these are the frictions, are very important, especially in the leg, the tip of the leg of the robot, because you want very high friction there. So if we have a look, yeah. So basically here, the contact where the leg makes the contact, you see that the friction is 10, while in other elements is 0.5, which is very slippery. Yeah, because we want basically the friction is on the tip of the leg. Okay. So that's it. So we have to convert all of these links into the basic physical entities. So let's do it step by step. So first the base, I'll copy paste because that way we are going to go faster. So the base, then we put this gazebo. Here we can put the materials. Okay. Then hip assembly, materials, upper leg, lower leg. Okay. And then, as you can see, we added a new element, which is the contact sensor link, which is the sphere of a certain radius. This is because we want to use it for the contact sensor afterwards. So we'll add this new link and this joint, which we don't have here. Okay, it's connected to the lower leg at this distance. No problem there. Okay, forget about the contact sensor, the emu for the moment. We have the joints, the transmissions, we forget them for the moment. So that's it. So now we have like the basic geometric shapes of the robot. Yeah. So how do we spawn it? So how do we go here to our simulation and use it and make it appear in a world? To do this, we need some extra steps. So first thing, we have our description. This, we don't need to edit it here. So here in a My Leg Robots Simulations, we have to add a worlds folder. This is the first thing we have to do. So let me copy basically this folder, which has 2 worlds that we are going to explain. Copy, paste. Basically, to do a folder, if someone doesn't know, you just have to right click on the folder, the parent folder, and then new folder, and it will create a folder. So nothing very fancy here. And to create a file, just right click again, new file. Yeah. So let's have a look to lowgravity.world. It's a very simple world with just a tag that allows us to change the gravities. This is very useful for legged robots, because if we want to just test that everything works, but we don't want it to fall to the ground, we just have to deactivate the gravity like this. 0. That's it. Okay? And you're saying, okay, and how do we launch this world? Well, for this we have to create a folder which is called launch. And inside it, we are going to do a main.launch. And inside it, we are going to launch the world. So let's see the example here. So we're going to copy, and we're going to, let me close this real fast. And we're going to copy this and select that it's XML. Okay. Do we need this? No, we don't need this. This we don't. This will do it afterwards. So I'll just comment it and we'll uncomment it. And we also will comment the spawn for the moment, and we are just going to launch our new world. For this, here we state the debug, if we want GUI or not, headless, well, I think paused, in this case we don't. Basically the only thing that we need to state here is if it's paused or not, and the world file. In this case, well, my package is called like this, so we're going to put like that. And worlds, low gravity, perfect. And that's it. So now let's have a look. We go to simulations, we go here, and we look for our package, My Legged Robot Sims, main, and launch. And it's very important that we look for any errors that might arise when launching the world. Okay, connected to simulator. This means that everything more or less went well. You see that the time is clicking. Perfect. So we have our world. How's the gravity? Well, let's have a look. So we put this here. It doesn't fall. Perfect. So this is working. Okay, so we have a world, but this is not very fun. So let's spawn a robot. For this, we go here and we create our spawn robot, so we're going to call it like this. So we go here, new file, spawn monoped, and inside it we're just going to copy this, and I'm going to explain you more or less how it works. Okay, we have to, so essentially what we are doing is launching this launch, which is called spawn robot URDF, which is a launch that we have installed in ROS Development Studio, but it's basically spawning a URDF. So we have videos about this, so you want to know how to do it, please have a look at it, but if you're curious, just to show you that it's nothing special. So we go to launch and spawn URDF, which is this one. Sorry. There we go. So as you can see, it's very, very basic. It's just loading robot description, and then we load the URDF that you give it into the world using Gazebo ROS package spawn model. Yeah. But I mean, you don't need to know how this works. You just use it and it works. But for people that want to know it, there you go. Also, you can do the course on Robotic Ignite about URDF creation, which is explains this in much more detail. So basically, we have this, and now we state where do we want to spawn the robot, in what position, in which position, and roll, pitch, and yaw, in which orientation, and then which URDF we want to use. So in this case, we don't want this one, we want the one in this package. URDF monoped controlled. Exactly. So now we are going to launch it. So we can go, let me open here one. Yeah. So here I'm going to do CD simulation. Okay, let's spawn. And there you go. So as you can see, it's not falling. It's not falling because we have gravity 0. So it won't fall, no matter what we do, okay? But let me, for example, if we spawn a cube here, no, there you go. It's just the physics are starting to go crazy, but as you can see, it's working. There you go. There you go. So it exploded. Yeah, perfect. It worked perfectly. Okay, and you say, okay, what happened there? Is there something wrong? No, it's totally normal in a simulation. So if you spawn an object inside another one, it just goes crazy. So the good thing about this is that we just have to launch again a world, and we will have everything perfectly set up. There you go. So if we launch this again, there you go. So you can see that it has the blue element here, which we stated here in our launch. Here. So we have blue. The color that you will see in the simulation is the one from Gazebo. This one is for RVs. Things that happen with this, with ROS and Gazebo, sometimes they don't mix well together. But we have our robot. But what happens? Well, basically what happens is this. Let me show you. If we put a gravity, let's say, minus 9.81, which is gravity on Earth, and we relaunch this again, let me check that we have gravity. Okay, perfect, we have gravity. And now we're going to spawn a beloved robot. There you go. As you can see, it's not actuated in any way. So what do we have to do? Well, we have to add control. So this is the second part of the video. Let's make a pause and continue later. And that was it. In the description of the video, you will find a complete course to URDF creations and also to control in Robotic Night Academy. So please check it out. If you had any doubts or you want to go deeper in this subject, if you didn't like the video, please give us a thumbs down, but if you like it, thumbs up. And consider subscribing because we publish videos every day. That's it. So thank you very much and see you in the next video. Hasta la próxima.